I think we're going to get started when everybody's ready. So I'm RJ McDown, and this is Josh Timer, and we're going to be talking about Windows Rootkit development, Python prototyping to kernel level C2. And so I'm a senior consultant at Ernst & Young, and I'm on their attack and penetration team, so we do like red teams and all sorts of different stuff. Before that, I was in security monitoring, that's on the blue team side, and then computer science, that sort of thing.
I'm Joshua Timer. I'm also with EY. I'm also based out of the Advanced Security Center, primarily doing attack and penetration, and then assisting on some incident response jobs as well. So we're both primarily red teamers, and as we go through the testing and as we go through this process, we run into a number of issues, right? Ideally, we're stuck between trying to get to certain trophies on the network and at the same time trying to minimize our footprint. And so this is something that pretty much everyone struggles with. Regardless of the tool, Metasploit, Empire, Cobalt Strike, you're going to have either network traffic, event logs, or authentication activity.
Yeah, so that's like some of the things. So like network traffic, obviously like IES's netflow data. One of the things that can get people caught oftentimes is if you pull down you get a stager going and then it pulls down the second payload and it's just default and it's not encoded or it's not encrypted or anything. That can be like issues, and then just common non-encrypted traffic. So like if we have some sort of like command and control, there's like orders can go on that. Event logs too for logins. And one of the big things now is like anomalous activity. On the network, we see a bunch of logins from this one IP, but that's not typical for our environment. So what's going on?
I'd say most of our clients are aggregating their Windows event logs at this point, right? So as we go through and we perform the activities or the attack and pen activities, we're creating logs. And even if you were to clear out the logs, what you end up with are abnormalities where a host is not reporting its logs, and so as a result of that, it looks bizarre and warrants additional scrutiny.
Yeah.
So ideally, what we like to do is, as we go through the process of attacking a network, we want to try to hide our network connections. So that is on host-based firewalls and wherever there's logs that wouldn't show up. Additionally, we would like to try to bypass certain firewall restrictions that are in place on certain hosts. From a diversion perspective, if you're in some sort of purple team environment where there's a blue team actively hunting you as you're going through the process of testing, it'd be nice to try to divert their activity, show false positives, essentially try to move the attention away from the attack and to something that isn't necessarily related to us. And then finally, whatever platform that we're using, we'd like to weaponize it for our common tools where we're trying to gather credentials and everything like that.
Yeah. And one of the things, we're going to have like some really awesome demos and everything, so just hold through to the boring part until we get to that, because we'll dive into demos and it'll be less text and more hands-on. So, yeah. So, but that's kind of the thing is like, so since we've run into these issues, we were just kind of thinking, how can we get around this? How can we, what can we do that isn't actively being done possibly? Or, like, can we do something different? Because typically that's kind of the trend is like, oh, we'll do like one thing. Like, it used to be like SA blank, and now it's, so there's like a trend, and sometimes you go back. So we're like, what can we do that maybe is a little different to get around things? So it's really kind of starts out with understanding how does Windows work as far as like the network stack. And so the Windows filtering platform, there's an API set that Microsoft provides to allow us to interact with the network stack the way that it does. And so, for instance, the Windows, firewall, antiviruses, a bunch of different stuff, they actually use these APIs to do that. So Windows Advanced Firewall, it uses these API calls. It's like a low level. And so the WPF is the newest, it's the standard. So like those APIs are what's being used. It's replaced, the transport driver interface, like all those ones that were just like predecessors to this. And so understanding that it's, blocking stuff at a, at that level with these APIs and we have access, okay, what's the simplest solution for us to employ something that we can use to leverage that same low-level control over the network traffic, and then also what can we do with it?
And this is really where WinDivert and PyDivert come into play. So there's, from our perspective, how do we rapidly prototype something that we can use on an engagement? How do we see what we can take advantage of, what we can spoof, what we can change? And so there are current libraries out there, primarily WinDivert, which is it's an open source, trusted and signed network driver. So you could actually sign this driver yourself as well. And it allows you to take control of certain network packet processing away from the host operating system, and it's capable of allowing you to really manipulate that traffic. PyDivert is really just a wrapper around WinDivert. And so there's a number of tools that are currently using this. Anything from FireEye's, fake NetNG, where they're spinning up a fake network in order to do malware analysis, to, the list is there. This is off of WinDivert's site. So essentially, this looked like it was something that we could use, that we could interact with to try to get to the underlying operating system at the kernel level.
Yeah.
So.
Yeah, and I mean, just to kind of add to the project, it's legitimate. Like, that's why we kind of put that list there, is that, when we get into basically how we're able to leverage it for our activities and things that we need to do, we definitely don't want just, oh, hey, let's just block that driver, because one, it's open source, so anybody that gets, for like, even for Windows 10, we get an EV, code signing certificate, it's going to be different, and so simply blocking the driver isn't, don't do that, because legitimate applications use it.
Well, I think and going forward, so, there's a user mode and kernel mode, and typically you haven't been able to interact with the kernel mode drivers up until around 2012, where you can now actually, as an individual, obtain an SPC and actually sign kernel mode software. So WinDivert is one thing, but at this point you can ultimately take your own and sign whatever you need in order to interact with kernel mode drivers. So WinDivert is primarily, the two pieces that we're using are the WinDivert sys file, which is really a kernel mode driver, and then the DLL, which is the user mode library that interacts with that kernel mode driver.
Yeah. So it's really awesome, because now we have access. So we can have user mode code that's interacting with kernel mode stuff. So it's pretty good.
Why don't we show them that?
Yeah. So I think we'll just go ahead and hop into a demo.
We're going live here, so
yeah, we were gonna make videos, and we were like, whatever. So we'll see how it goes. Okay. And so the first thing that we want to look at is, okay, so like let's say that we got on this box, and we want to come back, because in a lot of cases, in a lot of environments, what typically has to happen is that, they want us to see if we can get to a specific segment of their network. They want to see if we can get to this objective. And usually it comes down to, okay, we have to go through a jump box, and then we have to get to that network, or a series of jump box. So that was kind of, like one of the inspirations, like, okay, how can we, do this where we have to, log in multiple times. It's going to be weird traffic, so that's just kind of the thing. But, so
So we've written a Python prototype using the WinDivert, and we've compiled it to an executable. All of this will be open source, and you can make your own executable. And so this will be up on the GitHub page. But essentially, what RJ is showing right now is the fact, if you're on a machine and you log in, you're creating event logs associated with your activity, right? So,
right.
I mean, it's not only creating authentication logs, but it's showing up from a network perspective.
Yep. And so like this program that you can probably see on the desktop, that's just that's the binary. And so we use PyInstaller with a spec file that was a little bit of getting it working, but now it's flawless. So if you go to compile it and you're modifying the spec file, it's probably doing something wrong.
The instructions are on the GitHub page, but let's go ahead. Why don't you show them the logging platform?
Yeah. So what I'm going to go ahead and do is kind of show, one of the things that we use a lot on engagements are just like Impact. It's a great tool. We can use like WMI exec, PS exec, different things like that, just to get remote access. So if we want to go ahead and get on this box and we just want to use PS exec, for instance, let me make sure that it's logging. Okay, good. Yeah, it is logging. So we can easily get a shell, who am I, network system, and then we are on that box. So 146, that's the target machine. So when we go through the demos, that's going to be the target, is 146.
Yeah.
All right.
So this is the box that he's essentially PS exec'd into, right? So, and it doesn't really matter what you're doing, RDP, PS exec, whatever. This traffic is showing up from a networking perspective. It's showing up from a
logging perspective. And if
so,
you do,
Netstat, the logging platform.
Yeah,
too.
and just to show we have an active connection. So the 147 attacker machine, 146 is the target, and it shows we have an active connection. So if we come back over here, it's like the last 15 minutes or so, you can see that in the logs, administrator logged in from this IP address. So our attacker machine will show up in the event logs, right? So boom, it's like, oh, hey, we've never seen this IP log into our jump box. What's it doing? Bam. So
he's exited out of that was the previous connection. Those were the network connections that showed up. So now we're going to run this tool that interacts at a driver level, a kernel level driver.
Just to see if we can maybe
just to
get
see
around
if there's some ways that we can bypass some of the typical stuff that would show up in the logs.
And so I think we probably want to make it a service just because we're not going to run it
so
from the command line, right?
One of the ways you can one thing you can do if you want the executable to persist is really to turn it into a service on the host operating system, right? There's a number of ways for persistence. It's arbitrary, but go ahead and
And I'm going to copy and paste just so there's no issues, because we know how demos go. Yeah, copied. But if we look at it, we're basically just creating a service, and I'm actually going to give it a different name because that one might actually exist. So we'll call it, just
Derbycon.
Oh yeah. Derby red cells.
Okay. So what he's done is on the victim machine, this assumes that you have some sort of access on the victim machine and you're trying to persist. So what he's done is started a service on the victim machine. Yeah.
It's right there.
So there's the service. It says, from when you're listing your services, it's essentially saying go ahead and start the service. Obviously we've created that service, and so
I think we can actually do the net star, right? If not, we'll do it from the GUI, but I'm pretty sure this works. And so you notice that we got an error, right? But if everything went smoothly, let's just see what happens. So there's actually, inside this program, we've actually built in a backdoor. You want to go ahead and show like what ports are listening right now? Here, actually.
So that in the options, you're listing.
Yeah. So, as we can see, port 22, just like so we all know, is not listening, right? So there's no service listening on port 22. If somebody opened this up, nothing's on 22. But we ran our program. We're connected. Let's see. Okay, we're system supposedly. Let's see what box we're on.
What's your RIP?
146.
So you're on the victim machine. So.
And this is a TCP connection. So does it now show our active connection now that we're connected? Does anybody see 147 listed? No. So we're able to maintain a stateful TCP connection without it being listed here.
Shut the logs.
Yeah. And so let's go ahead and see, were there any logs associated whenever we made a connection? No. Because these are from...
Nothing new showed up in terms of,
12 and it's 17.
Okay.
So nothing new. It gets better. It's better.
So the next thing, so obviously the Windows firewall is also using this, right? So if you have a host-based firewall that is blocking certain ports from actually being able, from services being able to communicate over them, it doesn't really matter. So if we were to turn on the Windows firewall, it wouldn't make a difference. We could pick whatever port is being blocked and ride over that port.
Every port could be blocked, and we could still connect to it. And nothing would show up.
As long as the executable is, as long as you've run that executable.
Oh, and remember how we started the service? Let's see if it shows that it's actually started. No. So we have, we started as a service. It doesn't show that it started. We're listening on a port. It doesn't show that it's listed. We have a valid TCP connection, and it's not listed. We're happy about that. You want to go back to the...
Sure.
Okay. Yeah, we'll do that later.
So just to recap, what we're trying to do is handle the connections manually and then divert the packets away from the stack and then manipulate them in a manner that we want to use them. So ultimately what we're trying to do is limit what's observable by the operating system, and at the same time try to hide the network activity that would be reported. It allows you to bypass firewalls and interact over a block port really without the restriction, if you're using the Windows Advanced Firewall, so the native Windows firewall on a host. So a lot of those connections are, or a lot of that network traffic really would have to be detected from a network appliance. It wouldn't necessarily be something that could be reported from the host.
Net flow data. Oh, yeah, I think I'm fine. I'm sorry, what? Oh yeah, no, it doesn't matter if it's running or not. And the reason why is because it's using the same APIs. So when we take the packet off the stack, do whatever we want with it, we send it back, we're operating on the same level. And that's why it goes through.
Yeah, kind of going back to this, I mean, pretty much that Windows firewall is operating at the kernel mode driver. It's using this, yeah, go ahead.
If we haven't implemented, the driver that we're implementing, we're really taking advantage of, specifically for this, is really focusing at a network level. But we can, definitely explore other venues, and this can definitely be extended with other drivers as well. Yeah.
So,
And just from a development perspective, we kind of wanted to show what's kind of the logic behind this. How are we able to do this? What's the secret sauce? So
there is none.
Well, it's just like a real big pain is really what it is. And so what we ended up doing is like, if anybody's used Scapy, which is awesome, it works really well, except that, you're not able to modify packets in transit. You're able to just kind of get a copy. And so with this, it's kind of like Scapy, but you can modify it before it goes out. And so what we did is we implemented TCP manually. Okay, so like we have like basically it's not going to be RFC compliant. Okay, but it's under active development and it works. So like the client that we're using is using Python sockets, so it's able to maintain a valid TCP connection, calculates the sequence numbers, all that. And so like you can just kind of see a code snippet here. This can definitely be looked at as almost like a state. I mean, it's not a state machine, but we're basically trying to keep state. And so we have records that show us, like, if someone makes a TCP connection, we can then see, okay, is there a valid connection for that? And we have, code that's basically handling each, use case to keep that connection alive. Good there. Yeah. Can you give me more detail?
Please repeat the question.
Yeah.
So if I were to run a message trace on a compromise system and get a netball or
Oh yeah.
trace, would those packets also be suppressed?
So what happens? Okay, so basically he wants to know, would we be suppressing packets? Like, I think the question is, if you're monitoring traffic with maybe like Wireshark, TCP dumper like that on the compromised host, would you still see the packets?
Using message trace.
I'm not sure. We haven't tested it. I wouldn't want to say yes or no just because we haven't looked at it. But I will say that what happens is we take it off the stack and we put it in. And so like whenever they're using like, WinPCAP, for instance, and it goes into promiscuous mode, it's able to see those packets, right? So like we can like see that. But from like a host level, it's not making those. And we're going to go into basically like some other ways to even break those connections too. But is that? Okay.
Yeah. Sorry.
Hey, it's open source. We can test it.
We can test it after if you.
Yeah. Okay. So goal 2, we really like some tools that require authentication. Like Mpacket's really good. It's very powerful. Sometimes we have to remote desktop. There's been some cases where that's going to be the only
and a lot of
allowed.
industrial control systems networks, SCADA networks, a lot of times they'll block everything but only allow RDP through for an operator, right? So you're forced to use something that you wouldn't normally use, right? You're forced to try to obtain the credentials that you need, keylog someone, pull what you need, and then make that connection to prove that you have that access to that restricted host. So one of the things that we wanted to do was try to use those tools, even something as simple as remote desktop, without having it show up without having it show up in a way that it would give away where the attacker was, right? So try to divert what's actually happening and show something else. So in this case, go ahead.
Yeah, we'll go ahead and demo it because we'll just kind of see what happens. So like on this box, we can make an RDP connection to it. And so from our attacker machine, probably be faster just, oh wait, wrong box. Yeah. So Tyrell Wellick, he's an admin of the box. So we're going to use his account. So remote desktop in. Oh, my bad. Thank you. Let's try it now. Boom. All right. So we're going to go ahead and use this account to log into this machine.
So obviously this assumes some level of compromise on that host, and what you're trying to do is persist on that host and log in continually, or be able to log in when someone else is logged in order to do something. So From our perspective, what we're trying to do is run something that would allow us to connect to a victim machine and divert the traffic. So report something that isn't actually happening, change some of those IP addresses so that if someone were to look at that, it wouldn't directly give away where the attacker machine was coming from.
Yeah. So just to kind of like show, as far as RDP logins, we don't have anything in the last 15 minutes. So we're going to go ahead and get on this machine. It takes a minute.
So again, this is focused at a network layer, right? So we're still doing an authentication. We still are using remote desktop. And this is something that is going to occur. It's going to create some sort of authentication log. It is from an authentication perspective, the way that this tool has been implemented. But that doesn't mean that that's what's going to show up when you look at the network connections, right?
So we have a valid remote desktop connection. Let's see what it says about our connection. It's kind of small, isn't it? Right here. So here's our remote desktop connection. Oh, what do you know? It's all loopback. So our 147 remote desktop in the machine from 147 into 146, and it shows loopback traffic. Now, cool, but what do the logs say? Okay, moment of truth. Are we caught? No. So the logs in Windows that would go up to Central Logging Server said somebody authenticated with RDP on loopback 127. I'm sorry, what was that?
The question was, is loopback a requirement, or can you set something else, right? And so that's going back to the...
Yeah, go for it.
Sorry, this one. Going back to it. Right now we've set the loopback as the IP address, but this could be set to anything. And additionally, what we'd like to do is try to chain agents together. It's a to-do, so that essentially you could issue a command and it'd go through a series of agents to get to where it needed to be, and create what you could end up doing is creating a bunch of
chaos
essentially as the agents work together. So it's on our to-do, but from our perspective, the thing that's awesome is since everyone's relying on these event logs for their monitoring, if the event logs start lying to you, at that point, do you really know where the attacker is coming from, right? If everything's coming from the loopback, it's going to require some sort of host-based forensics. Then it would show his legitimate IP address.
Because we're able to maintain state between our connections. So just like TCP does, we're able to track sequence acknowledgement numbers with the offsets of the payload size. And so we're able to track that, keep state, and make sure that if a legitimate person tries to RDP in, go in over SMB, we're not taking, or even internal SMB traffic, we're not taking that traffic and causing downtime.
So the model, the deployment model,
and the question was, how can we differentiate between legitimate and illegitimate traffic? Right. That's what. I like the way you think. Yes, I mean the way that's we did it is that the current version of the program, it has a command line interface, so you can specify who the attacker IP address is. But again, this is under active development. And also all the traffic is fully encrypted with AS256. Please scrutinize how it's been implemented, because that's typically, there's been a lot of So anyway, the back door that we showed at the very beginning is encrypted, and the way that it's implemented now for the proxy is you can define what the attacker IP addresses is. So in a future version and release and stuff, what we're planning on doing is basically making an authenticated or encrypted like configuration control over UDP, so that if we need to change the IP address that the attacker is going to be coming from, if we need to have multiple IPs, multiple instances, we can control that stealthily over that. Yeah, yeah, and we're maintaining state like that that's how we're able to track it, so that we don't cause downtime for people that are legitimately logged in.
So there's another question.
So it would be possible for the engineering to pull a string of the packet that gave us out of memory to store that somewhere.
Oh yeah, I'm really glad you asked that, because that was kind of a pain. Because the same thing.
So the question was, would you be able to pull the attacker's IP address out of memory to try to recover where the attacker is?
Yeah, and the same thing, in the same question we asked for the password. You know, it's Python, so del, the variable, does not work. So we have we have a function in there that uses the C types, and we calculate the offset of the variable for the password. I'm glad you mentioned the IP, because we can do that too. But the password specifically, we calculate the offset, and then we use the C types, mem, to overwrite memory directly, so that whenever it spins up, the password's not in memory. And that's one thing we really want to make sure of. So I'm glad you mentioned the IP too. We can do anything.
In theory, you should be able to overwrite.
And the other thing is, right now we're actively moving this to C as well. And so, because I like this way more, because you have control. Because it's already configured. So whenever the service starts and it's running, then it's already there. So the traffic, we're using the PBK as, it's basically the key derivative, or derivation. And so whenever it gets the derivation of it, then it'll have the hash there, but it won't have the plain text. So we're using the key derivation versus just, plain text password.
Question.
So you're doing reversion protection within the tool, and then you guys are doing SOCAT implementation where you're really back to looking at it. Could I recode it to like reversion protection RDP? Why didn't you do that?
Oh, well.
Just open yet another invisible connection. Any log is problematic. With this loopback, then actually my log likes connecting to RDP on itself.
Because you still have to authenticate, so the authentication shows up. And so the other thing is that it kind of gives us an advantage, because if they have a bunch of traffic logging into this jump box from, let's say, legitimate admin's workstation, we can use that same technique to show that it's on loopback to make it look like it's coming from that machine. So we can make it look like we're coming from somewhere that we're actually not, which is a pretty big advantage. What was it?
Can you snoop for other connections?
We're operating this at the same level as the Windows Advanced Firewall, right? I mean, we can do whatever we want with the traffic. Anything.
And it's all open source, so
Yeah.
feel free to add. We'll gladly take any help.
Yeah. And here's actually kind of the a little bit of the logic behind the spoofing of the loopback. It was kind of like an accident, but anyway, so what happens is that we have our filter set up, we know where the attacker's coming from, and so what we do is we change source destination, but the other thing is that we have to change it from, the standard WLAN interface, or the, E0 or whatever, it's interface, to basically the loopback interface. So that's one thing. We change the interface, and then we have to change whether it's inbound or outbound. This was the weird part, maybe you guys knew about it, but for loopback traffic, it's always outbound. So whether or not we're sending it inbound, like we're spoofing inbound, it's outbound. And then whenever we're spoofing, back out to the attacker, it's outbound. So in WinDivert and PyDivert, you can set the direction of the traffic. And so it's important here for the loopback specifically that the direction both ways is outbound. And then it works, because otherwise it doesn't work, and it's gonna be a huge headache. But then, yeah. So that was kind of the key
Why
thing.
don't we jump to the next demo?
Okay.
We can just talk through it.
For the
So another piece that we wanted to try to incorporate into the tool. This is great. You can use native tools. You can PS exec in, but can you use it as a platform in order to run certain scripts? So specifically, we're typically focused on trying to get passwords out of machines to try to find the machine that we're after. So ultimately, if we have a tool where we can't use it to run PowerShell or run commands at command line, then the usefulness of the tool becomes a moot point, really.
Right. Yeah.
So what we've done, and this could, you can pretty much do whatever you want, is we've just changed, we've created essentially like a PowerShell shell, so that you can access either the shell itself, the cmd.exe, or PowerShell, and run and call PowerShell and essentially run whatever commands you're after.
Yeah. So we're just going to kind of go ahead and show that, and let's just make sure that we're connected. Yeah, server system. So just to kind of show, so here's the distinction between, if you want to do shell, then it's going to be that way, and then just to do the PowerShell, it's just P shell. And this is, I don't know if this is messy or not, but either way.
So
go ahead and speak to this really quick.
Go ahead.
Go ahead and talk
So
to it
obviously we're using the download cradle, and we're hard linking invoke Mimikatz. So don't do that. Host your own, and don't pull it
from the
theirs
GitHub
directly.
repo.
But
For
for demo purposes, we just wanted to show that this is something that we're pulling, from some other source that is outside of us.
So sorry.
Yeah. Sorry. Yeah.
Don't
Do
pull
not.
it from the GitHub. Okay, cool. So now we have creds. So invoke Mimikatz. Oh, and let's see. We're running, and this is running PowerShell version 5 with full logging too. So.
Is the driver spawning a PowerShell process or
What's that?
So the question was, is the driver spawning a PowerShell process? In this case, what we're doing, just as a proof of concept, is just calling PowerShell.
Yeah. There it is. So, being hard credentials that way, and obviously, with this level of access to the network traffic on a machine, any sort of plain text protocols, we obviously have complete access to that. Good.
So ultimately, what we'd like to do is passively harvest credentials from clear text services that may be running on something. So in some cases, we know someone's authenticating using Telnet, like a network admin may be monitoring his switches. Believe it or not, Telnet's still around. So what we'd like to do is try to implement some sort of passive monitoring to extract credentials out of what's actually occurring. And at the same time, another thing that we'd like to do is implement some sort of keylogger.
Which is pretty trivial. Yeah.
Time check.
Yeah, it's really.
So there's a number of initiatives in place.
Yeah, so I mean, one thing is we really want to move it to C, because we started out, is that we can do all that in Python. That was all Python. But you kind of get to a point where just clearing stuff out of memory, having that lower level of control, even doing some debugging, mitigation and sandboxing stuff. It's doing it in C has benefits, and so with the WinDivert API in C, it's actually not that difficult to really port it over. So the really good thing is in Python, we can prototype this stuff. Oh yeah, this actually does work. We're able to do this thing, and then we can spend the time going into it and making a really stable thing in C. Plus, also the WinDivert in C supports asynchronous I/O. So for speeding up, it's really good.
One of the things we've kind of tossed around is, when we set these network connections, setting them to arbitrary IP addresses, or making them look like legitimate, making them look like DNS traffic, between a a domain, making it look like it was DNS traffic to a domain controller, which is often a DNS server, or setting it to IPv6 addresses, because we know everyone looks at IPv6, right? So
who understands the addressing? Like,
so trying to hide or blend in with the environment more. So there's a lot of to-dos, but it works in its current state as some sort of, command and control at a kernel driver level.
Yeah. And just to kind of follow up, like, whenever it fully supports IPv6. So if we want to do the IPv6 loopback, that would be even less obvious. And
So,
a lot of IEDSs don't support IPv6 too.
So what does this require in terms of dependencies? Really, it's just a couple of packages which you can pull down with pip, and then PyCrypto has a reliance on the C++ compiler for Python, and to roll your own exe, this, if you were to go to the GitHub and pull it down, this is all you need to do. So you could set your own passwords. You could hard code your own passwords if you wanted into it, change it out. Obviously, you can have a flag to overwrite some of that, but that's really what you need in order to deploy. It's literally that simple. And then
and it's standalone. So it pulls all of the DLLs and the drivers and stuff into a standalone binary. So it's extremely portable.
And if you don't trust our WinDivert, DLL, and sys, you can
Your own.
It's open source, so you can build your own as well. So and this is all on the GitHub page, but it's to show that there aren't, you're not walking into a never-ending dependency hallway, where you don't see light at the end of the tunnel. This is literally what you need. From a services perspective, we kind of talked about starting those services. This is literally just recapping, how you'd run that exe and set up some sort of service that would run. There's a number of ways. You pick how you want to persist, but
I think we actually listed there and some other things we were going to talk about, but time-wise. But yeah, the service is great because we can start it and it shows that it failed to start, but it's actually running. And so if someone's like, "Oh, is that a suspicious service?" They go to look at it, "Oh, it's not running." So, yeah.
So from a defense and detection perspective, you can certainly look at the authentication activity to try to find real abnormal use cases where you would show some sort of persistence is in the implementation or the use of the exe in order to establish some sort of persistence. So you're looking for process creation or something that's registered on the host-based operating systems. Right now, the way it's implemented, whatever commands you execute on the underlying host operating systems, for example, PowerShell in that example, you would still see that happening. It just wouldn't. You'd see someone ran Mimikatz and you'd see the commands, but it would be hard to attribute it to a specific attacker.
Yeah.
And then at a network level, you can hide on a host, but you can't hide from network appliances. Now,
that's actually a feature too.
Yeah.
Yeah, so one of the features too that we're going to talk about, because that was one of the big things. Okay, yeah, we can hide from host-based traffic, but what about if someone's actually looking at NetFlow data? How can we possibly mess with that? And so, because just like the loopback, we're able to change the source and destination IPs and the interface and everything, we can actually hop around and make it where it's whenever it sends the response from the target back to us, the source address actually isn't the target that we're attacking. And so we can dissociate IPs from all over the place. And because we're controlling the traffic, we're handling the connection from the client side. Once we have that implemented, we can really make it look like whatever we want.
So that's really it. This is not yet public, but we'll
do it today.
Flip it today. We promise. We just forgot to do it before the presentation. And then feel free to reach out to us with any questions. We'll pause now if you have any questions. Otherwise, thank you very much. We really appreciate it.
Thanks. Cool. All right. Appreciate it.
So basically, doing asynchronous communication, you're going to disassign your outbound source IP, and then it's free, like how this is something you already tried, or
Yeah, so the question is basically disassociating or changing the source IP whenever we're coming back to our client to make it look like it's coming from somewhere else. Yeah, we've been testing that, and one of the first things was the loopback. But whenever we put that on the wire and we change the source, typically it would just be like, oh, RST, because it doesn't show that stable connection. But since we control the client and the server, we can maintain that stable connection by implementing it ourselves. The sequence acknowledgement numbers, and then the payload size. And also the really cool thing about this is that you have control over, you can implement your own protocol if you want to. I mean, so we can, yeah, absolutely, yeah. Exactly. And we're trying to make a socket import. So it's basically like a WinDivert socket. That's what we're trying to work on. So basically, whenever you go to develop something, you can import it just like you would a Python socket. It's like import sockets. And you can develop your own modules without having to worry about the TCP handling because it's already done in a library, which would be cool. Yeah.
Thank you.
Thanks.
And any other questions? Thank you.
Appreciate it. Thanks.
where are you guys at?